So the cosine law is a supplement to the sine law. So when we can, we try to use a sine law because the sine law tends to be a little bit easier to use. But the cosine law is just as valid and it's very useful. And essentially, it is a variation of Pythagoras' theorem. Okay, so let's take a look at Pythagoras' theorem on a right triangle. So here I've got a Pythagorean triple. This just could have been any right triangle, but this happens to be a Pythagorean triple. This is 4 squared plus 3 squared equals 5 squared. Okay, so that's a right triangle. And when the angle here is 90 degrees, okay, we can use the Pythagorean relationship. And we know that the square off this side, square off this side equals the square off of the hypotenuse side. So what happens as we change the angle from 90 degrees? Okay, so let's say that this angle here is less than 90 degrees. Okay, so what would happen if we kept the same sides, 3 and 4? So this is length 3, this is length 4. And what's going to happen to that opposite side, side C? Well, we kind of know from the sine law that as this angle shrinks, this side length will get smaller. Okay, so side length, what ends up happening, and I'll just kind of summarize it here. The side length is going to be less than 5. Okay, and the cosine of an angle less than 90 degrees, okay, cosine of the angle less than 90 degrees is going to be between positive 0 and, this is, I should write this out, should be less than 0, and the cos angle should be between 0 and 1. Okay, and it's between positive 0 and 1. So when the angle, remember, think of standard positioning. So imagine the circle here. This is our initial arm. As our angle turns this way, it's going to go from 1, as when the angle is 0 is going to be 1 all the way to 0. Okay? And the bigger the angle gets, the longer side C gets. So as the smaller it gets, the cosine gets closer to 1, and the further away from a length of 5 we should get. Okay, so the angle going from less than 90 degrees, so 0 to 90, is going to give us a cosine that's positive between 0 and 1. Okay, so what happens when the angle is greater than 90 degrees here? Okay, so that angle then is now obtuse. So what's going to happen to the length of side C? Well, we can clearly see that it is longer than that length of 5. So we're going to increase that length. Okay, so that length is going to be greater than 5. And what's happening to the cosine values? Well, as the cosine values get past 90 degrees, okay, remember that on this side, as we get past 90 degrees, the cosine values are negative. Okay, so we're going to end up with between negative 1 and 0. Okay, so this is going to be a negative amount. So as the cosine ratio goes from 0 to 180 degrees, so we have cos angle C starts at 1 and goes to negative 1. Okay, so as we increase this angle, we're going from a cosine value of 1 all the way to negative 1. Okay, so how can we relate the cosine of that angle, that length there, which is positive when we want smaller numbers, when we want that C less than 5, and when it's negative when we want the numbers, we want that length greater than 5. If we want to increase the length, how do we do that with a negative cosine? Well, ideally, we're probably just going to have to subtract some cosine amount. Okay, if I subtract that positive, I'm going to shorten C. If I subtract the negative, I'm going to lengthen C. And so when I look at the formula then, okay, so as I look at the formula looks like this. So it is essentially, and I'll just be very clear, it is basically the Pythagoras theorem. There's my Pythagoras theorem. Now, it is a Pythagoras theorem when the angle is not 90 degrees. When this is 90 degrees, cosine of 90 is 0, so this is just all disappears, so we just left with Pythagoras theorem. However, if the angle is less than 90 degrees, I'm going to subtract some amount. I'm going to shorten side C. If the angle is greater than 90 degrees, the cosine is negative, so I'm going to subtract a negative, so I'm going to lengthen it. So because I'm going to end up making C squared bigger, which makes the C side longer. Okay, so this is, we haven't really justified this or proved this, but there is a reason why it's minus, because the cosine values, when we want the C squared to be shorter, the cosine is going to be positive, so we need to subtract. When we want the C squared to be longer than our 90 degree triangle, we want to subtract the negative. Cosine will be negative. We end up subtracting a negative, which adds on to C squared, which then makes the length of C longer. Okay, so that's cosine law in a nutshell. You just basically need to know that it is of an adjustment of, it is essentially the Pythagoras theorem that accounts for non-90 degree angles. Okay, so that's how we're going to describe it then. Okay, so as I describe the cosine relationship is basically the Pythagoras relationship. It's the Pythagoras theorem when the angle is not 90 degrees. Okay, and so that's essentially the cosine law.